Is this working? I hope this is working. Hello everyone, it's Chow here, and today we are going to talk tonight we're going to talk a little bit about redox reactions. There are people currently asleep nearby, so I'm going to keep my voice down. So let's get through this as quickly as we possibly can, alright? So redox reactions. Most of you have had some kind of an experience in a chemistry course with redox reactions. So I'm going to keep it fairly basic and straightforward. Refer to your textbook if you need to for more practice and understanding, but let's just get through it as quickly as we can. So the first thing about redox reactions, also known as reduction-oxidation reactions, are basically reactions where there is an involvement in electron transferring. So you have one substance that transfers electrons to another substance. Now, in terms of definitions, oxidation is the loss of one or more electrons, whereas with reduction, it's the opposite thing, and that is gaining of one or more electrons. So that's something to keep in mind. Oxidation is loss, and reduction is gaining. So we're looking again at the transfer of electrons, right? And this transfer of electrons oftentimes is associated with the transfer of a hydrogen atom as well. So a hydrogen atom transfer is often correlated to redox reactions. So when a molecule loses a hydrogen atom, it becomes oxidized. So you lose a hydrogen atom, you lose electrons, it becomes oxidized. So these are very key, critical, important reactions that occur in the body, and one example is, of course, in glucose metabolism, where glucose acts as kind of the quote-unquote reducing agent. We'll talk about agents in a little bit, but glucose is the reducing agent and O2 is the oxidizing agent. Now, the terminology there is a little bit tricky, but we will define it in a later slide. So when you look at redox reactions and oxidations and reductions, there are some things that you probably should memorize, and this is actually two ways you can use to memorize what exactly reductions and oxidations are. So the first one is with this cute little mnemonic, I guess, and that is Leo says Gur, or Leo Gur, and Leo is, of course, losing electrons oxidation, so L-E-O, Leo, losing electrons is oxidation, and Ger, or G-E-R, is gaining electrons is reduction. So that's one way you can memorize it. Another way you can memorize it is with oil rig. It's not as good, perhaps, but you can think of it as oil rig. O is oxidation, I is, and then L is losing, and then it's implied that you're talking about electrons. And rig, which is R-I-G, is reduction is gaining. So oil rig, oxidation is losing, reduction is gaining, or you can use Leo Ger, which is losing electrons is oxidation, and gaining electrons is reduction. So those are just two ways you can use to help memorize oxidation versus reduction. Now, in terms of agents, that's where things get a little bit complicated. So the reducing agent is actually the one that gets oxidized. I know that's a little bit tricky, but just bear with me on this one. And if you look at it, you have some kind of a compound, for instance. So this is from a textbook. I think this actually is an older version of your textbook. But if you look at this particular compound over here, compound A, it currently holds 2 electrons. So right now it is actually reduced. So it's reduced, and it's going to act as a reducing agent when it reacts with molecule B over here. So at the very beginning, A is reduced and B is the oxidized compound. When you react those together, let's say A transfers those electrons to B. So A becomes oxidized with this reaction. So right now it starts off as reduced, reacts here, and then it becomes oxidized. So A here is oxidized because it lost electrons. Now if we look at the opposite end of here, you can see that B starts out as being oxidized, right? So you can see here that B is oxidized because it doesn't have those extra 2 electrons, and then it gains the electrons with this reaction, and so B becomes reduced. So B starts out as oxidized and it becomes reduced. Now in terms of agents, that's where things get a little bit tricky, because the reducing agent is the compound that is actually losing the electrons. It's the agent that's causing the reducing. So when you have a reducing agent it becomes oxidized after it reduces the other molecule. So it loses its electrons and becomes oxidized, but it acts as the agent that causes the reducing. So that might be a little bit tricky. Similarly, the oxidizing agent, on the opposite hand, is the one that actually gains electrons. So the oxidizing agent is the compound that is gaining the electrons, and so it's inducing the oxidizing. So that can get a little bit tricky, but I suggest you look at this or perhaps some other resource to try to get an understanding of this. And if you have a strong background in chemistry, this is just like easy piece of cake work for you. And so hopefully you get a little bit of a deeper understanding with this particular lecture, or if you already have good understanding, you can just skip the section. It'll be totally fine. So that's basically a brief intro on nomenclature. So when you look at redox rules, there are actually a couple of ways that potentially can be used to look at whether something is reduced or oxidized. And so the first thing that is often done in a biological system is you look at where the oxygen is in the products, in the reaction, or in the reactant, and then how many of there are in each particular group, the reactants and the products. Then what you want to do is determine the hydrogen count. So you look at where the hydrogen is in the products and in the reactants and how many of those are in each. Then what you do is look at the change. So if the product of the reaction gains 1 oxygen or loses 2 hydrogens, then it has been oxidized. On the opposite hand, if you have a product that lost an oxygen or gains 2 hydrogens, so if you think about gaining hydrogens, that's like gaining electrons, then it has been reduced. So these are some of the rules you can use to look at a large biomolecule and see whether it has been oxidized or reduced, or potentially neither. So there we go. Now if we look at a specific example here, we have NADH and NAD+, which are basically, this is a coenzyme that's found that's very critical in your body, for instance, for the electron transport chain, in glycolysis, in the Krebs cycle. So a very key coenzyme that's found in your body. Now, NAD+ and NADH are just basically oxidized versus reduced forms. So this coenzyme acts as an electron carrier in those redox reactions, which occur quite frequently in your glycolytic pathways, as well as your Krebs cycle pathways, as well as your electron transport chain. So it has an oxidized form, which is NAD+, and an unoxidized or reduced form, which is NADH. Remember, it gains an electron. It gains more electrons as a result. So if you look at the oxidized form, which is NAD+, it looks like this. And then through a reduction reaction, it actually gains electrons. On the kind of opposite hand, however, if you run the reaction potentially backwards, which can occur, for instance, at the electron transport chain, where NADH kind of drops off its electrons, it will end up actually losing electrons and ultimately be oxidized. So depending on the reaction, you can actually have the potential reaction going this way or the potential reaction going backwards. So you can actually have instances of, again, NADH being oxidized, so it gets its electrons removed and it loses electrons and ends up being NAD+. So again, that's basically the gist of it. If you look at certain biological molecules, you can see the gaining and losing of electrons via redox reactions. Or if you want to just break it down into very simple reactions between in just chemistry, you can still see instances of reduction and oxidation, but that's more of a general chemistry topic, and we're looking at broader realm biology or biochemistry topics, and oftentimes the redox reactions can occur with, for instance, coenzymes. So this is just one particular example of a redox reaction. So I think that's basically all I'm going to talk about in terms of redox reactions. I hope you all found this at least mildly helpful. And as always, I will see you in the next video, and best of luck studying.